Okay, this is going to be lab number 7, the last lab before the test, number 2. And today we're going to be focusing on program control instructions and specifically using the jump to subroutine or JSR instruction. So the actual machine we're going to use is one you have already done. So it is this box sorting machine from week number 2. So we are basically going to rewrite this conveyor, but we are going to do it using routines this time. Instead of just one big program, we're actually going to break the program up into routines. The other thing we're going to do with this as well, this time around, we've added in one additional switch over here, which we're going to use to just count parts in general. And we have added a couple of numeric displays. One that is going to display the minutes that the conveyor is running, the total number of parts that have gone through, and then we are going to calculate the total parts per hour that are coming along the conveyor. So let's get to it. So as far as the logic, you've already done this logic once. You probably did it with latches before. So we are going to do some nice seal circuit logic, and we are going to make all of our routines pretty much the same. That is going to be our strategy for this. So let's start off by laying out our program first. So everything we've done so far in this course has been programming within the main routine. So the main routine is the one that is executed all the time, no matter what, and that is defined, I believe, if you right click here, this is underneath program scheduler. This shows that the main routine is scheduled all the time. So this is, by default, this one is scheduled and will be executed. So the way that that works, if we want to use other routines, we actually need to jump to them. So let's start off by creating some additional routines. So looking at this machine, typically the way we would create routines, we kind of break it up into sections of what the machine actually does. So when we look at this here, we've got all of our conveyors, we've got pusher number 1 and pusher number 2, and then we want to do some part tracking data as well. So let's consider that. So let's go over here. We're going to go under main program and do a right click there, and you'll see add. We're going to add a new routine. So if we click there, and what we're going to do here is just put a name on it. It's going to be a ladder diagram. This is where you could select a function block or structured text or whatever you want. We were just going to do ladder diagram. And let's put a name on it. So let's call this conveyor. Now, one thing you'll notice is it will arrange things in alphabetical order in your list. So if we want to control how those are named, you'll see people often do this. Let's call this R01 underscore. You can't use spaces in here. R01 just meaning routine 1 underscore conveyor. And you'll see if I name them by this manner here, they will all show up in this order because it's R01 is basically controlling the alphabetical order. So that's one. Let's create another one. So again, I'm going to click on here. You could also create things by copying and pasting, but I'm just going to click on main program, say add. Let's call this one R02 pusher 1. I'm going to create pusher 2. I'm going to do this one just by copying this one. So I'll do a copy and then click on main program and say, oops, click on where does it give me the option to paste here? Copy, and under main task, Oh, I can't paste them because I'm in run mode right now. That's why. Alright, so we're just going to create new ones. There's things you can't do in run mode. Let's create a new one. R03 pusher 2. And then let's create one just for part data. So let's call this R04 part data. Alright, so now I have 4 different and these are basically going to be different programming areas. So you can see if I click on this, it actually opens up a brand new tab up here. So I have my main routine, I've got my pusher 1 routine, I can click back and forth between them. So now how do I actually activate these? Because right now they are not going to be scanned. So we'll look at the difference here. So let's start going with some conveyor logic first. So for our conveyors, let's make all of our logic fairly generic seal logic to control everything. So here's what we want to do to make our generic seal logic. So let's go with 3 lines, actually 4 lines. So let's make this, we're going to go with an output, a seal, which is going to be an open, a close, an output, and this. And then this. So this general structure right here this we are going to get very familiar with. So this is our seal. This is going to be our conditions that are going to end up right here. And this is going to be our result of this. So I'm now going to copy. So I basically I clicked out here, I held down shift, I did arrow down, and then I'm going to say copy. So you can either go up here and say copy, or I just do control C. I'm going to copy this, and I'm going to copy it into the pusher 1 logic. Okay, so you see how I have that in pusher 1, and I also have it in, oops, where did I put this? Did I put it under main? Oh, I actually did it in main. That was a mistake. I should have put it in conveyor. So I'm actually going to cut this. I'm going to do control X, take it out of the main, and put it in the conveyor. So you'll see how I have different tabs up at the top here now. I've got the main routine, conveyor, pusher 1. So I can click between these. So let's go to conveyor and write the logic for the conveyor. So the way we're going to do this, this is our main seal circuit here. So let's call this run conveyor. Remember, that's a new tag, so we need to create it. That also goes down here, and we're also going to use that down here as well. This one here is going to be our let's call it just want to be consistent with my naming. Conveyor start condition. That's a new tag, and that is going to be up here, and we're going to call this conveyor stop condition. just a new tag, and that one's going to be over here. So you can see start condition, stop condition. Use those two to create my seal circuit, and then use that run condition, run conveyor, to do whatever I need it to do. So now the trick is, what actually makes this start, what makes it stop, and what do we actually use that run for? So if we look over here, we have a start button, we have a stop button, we have an e-stop. Those are the only three things that make it start and stop. So for our start condition, I think this is just called start PB. That is basically our start condition. So if we push start button, we now get start. We will start. For our stop condition, this is going to be the stop button and the e-stop. Now remember, when we do these, it's going to be either of those will cause the stop condition, and it is the normally closed of these because those are normally open buttons. The stop push button and the e-stop push button. I don't know what the tag is, so I'm going to look for it. Emergency stop push button. There it is. So that's those. And then what do we use this for? We have all of these belts. There's a whole bunch of them. I'm just going to put in one. I forget what these things are called. If they're called belt or conveyor. Belt motor 1A, so we'll do that. I will put in the rest of them in a minute, but this is our basic logic for this. So let's see if this actually works. I don't know what belt that is that's turning on. Oh, I can't download yet because I have a bunch of errors. Okay, it doesn't like that I have these errors in here. It doesn't like that I have these. I'm just going to delete those for now. Okay, so this logic is now in here. Now, what you will notice, see how this is gray over here. There's no color. There is no green bars on the side here. Like if you look at the main routine, we know lights up in green on the sides. Okay, so these here are not currently being scanned. So the way that we do this we actually need to enable these routines that we created. So the main routine is being scanned all the time, but we actually need to jump to these other routines in order to scan them. So in order to do that, we go to our main routine and we need to put in what is known as a jump to subroutine instruction. So the easiest way to do this is to put in a new line. Double click over here and just type in a JSR, which is the jump to subroutine instruction. You can also find this over here under program control, but it will bring up some additional options which you don't want to really deal with. The easiest way to do it is to just type JSR. And then when you click on here, what you'll see is these are all of your different routines that you've created. So we are going to jump to the conveyor. And now when I assemble this, what you'll see, so I have green here, so that's being scanned. This is in my main. And you will also now see in my conveyor, the sides of this are now green as well. And that means this logic is actively being scanned as well. Okay, so that these were gray before because we had code in here, but we were actually not jumping to this part of the program. So now with that JSR instruction in here, we now jump to this part of the program. And let's see if this actually works. So now turning this on, so that seals in my seal circuit. I get one of the motors on. If I push stop button, that breaks it. E-stop also breaks it. That starts it up again. One of these belts in here is turning. I'm not sure which one. Okay, it's that one there. So that is the belt. That is 1A. Alright, so that's good. What I need to do now, there's a couple more things we need to do. We need to add all of the additional belts in here. And there's a whole whack of them. So what we are going to do is add a branch and do our add the branch level. Keep on adding branch levels. I think there's 9 altogether. We'll see how many we get here. And then I'm going to copy this instruction. I'm just going to copy this a bunch of times and change the name. So we have belt motor 1B, belt motor 1, belt motor 2, belt 3, belt 4, and there's the curved ones. And these are called, you can see when you name things, if you name things consistently, they're a lot easier to deal with. Curved belt 1. Now I'm just going to delete this and copy the curved, because that will make it easier. So now curved belt 2, and it looks like we have one more, which just curved 3. Alright, so that is all that. And the last thing we have, 2 lines for the lights. And this is just, if we are in conveyor run, turn on the green light. If we're on in conveyor not run, turn on the red light. So that was the stop light. And this was the start light. And this is basically if we had run conveyor. And this is if we did not have run conveyor. So, assemble that. And that should be all of our conveyor logic. So let's look at this. There's our stop light. We get green light. We get red light. And it looks like things are able to travel all the way through the system. Okay, so it looks like we covered all of the conveyors. That is good. Okay, so let's look at pusher number 1. So if we look at the lab sheet, or if we remember how pushers are supposed to work for this, first of all, let's start by just generally copying this logic here. So I'm going to highlight this stuff, copy it, go over to pusher number 1, and I'm going to paste this logic here. Now you'll notice, again, we are not lit up over here because we are not scanning this logic yet. So let's delete this, delete this, delete this. And this is our general structure that we wanted to have to start with. Basically something like this, and now we need to change some things and then fill in some things. So we're not talking about conveyors anymore, and the terminology of start and stop is not correct either. So let's call this, I'm just going to say P1 for pusher, and we're going to use the terminology advance and return. P1 return. Those are new tags, so we need to create them. And remember, this is now advanced and not returned. Let's drag that address there and drag this address here. So advanced, not returned. And this one is going to be P1. Now let's call it advance CMD for command, because we're basically commanding it to advance. So let's do this. And then this address goes over here. And now let's start filling in some. So that's a general structure there. Now, what makes it advance? What makes it return? And what are we trying to drive with this logic? So on this pusher right here. So if you remember the way that we did this one before, we have this photo eye right here. And I believe that is called PE1. And basically what we say is that if we see this photo eye, we should advance. So basically that is a tall or medium box. If we see that photo eye, we push, and that will keep us locked in on the pusher. What makes us return the pusher back? Again, we're going to return when we actually reach all the way across with the pusher. What will happen when we do that is we'll actually get this front limit switch will come on. So as soon as we get full extension on the pusher, we'll get the front limit switch. So that is called pusher 1 front limit, not back limit, but front limit. That is what will make us return. And then what do we actually run with this? It is the pusher 1 solenoid, because this is a single solenoid motion. Okay, so that is basically our logic for that. And then I think the other thing we did in this lab is we had one light here, and we said if your pusher was on, turn on that stack light, which I think is green stack light 1. So that should be our completed logic for this pusher. Now, you'll see again, this is not lit up over here. It is not lit up green. Let's watch this running. So these boxes should be getting pushed, and they're not. So you can see this here, that photo eye is coming on, but this is not happening. So the reason that's not happening is because this logic is not being scanned right now. So even though that is on, this isn't happening because this logic is not being scanned. So how do we get this logic to scan? We need to go back to our main routine, and we actually need to call this pusher 1 routine. So we need to add another JSR for this. So let's just copy this line. Let's go to copy and paste. And we'll actually do copy and paste for all of these. So let's add in pusher 1, pusher 2, and part data. So that should now scan all of our routines that we are creating. This is such a common mistake for people to create new routines and then not jump to them, so they are not being scanned. Okay, so let's watch this. I will assemble this. Once this comes on, we should see this guy get pushed. Because that logic is going to be scanned as soon as, so there, that's now being scanned. Okay, and there we go. So if we go back to our pusher, you can see It's lit up on the sides now. So now we got some nice clean logic here for pusher 1. Let's create logic for pusher 2. Now, since we had a good naming convention for everything here, what we should be able to do is just copy this logic, go over to pusher 2, and in this area here we should be able to paste, delete that empty line, and basically this should read as wherever we have a 1, if we change that to a 2, everything should be good. Now these tags we'll have to recreate. And if you do this offline, you can actually use the search and replace function, which makes you able to duplicate and create logic very quickly. If you were doing a large program, that is probably what you'd be doing, is moving to offline mode, copying, pasting, searching and replacing. That's what we'll do a lot of in PLC Part 2. And figuring out how to write programs that make it very easy to do that. This one here, I'll fix the tag for you, but I left off the T in the tag, so I have a spelling mistake in there that I need to fix. So now let's create this tag. Create, that gets rid of that error. Create this one. Gets rid of that error. Create here. Gets rid of that error. And we are now error free. We run this. So assemble. And this should all come up. We're already jumping to this routine, so as soon as we assemble this, we should light up in green. And there, and now we're good to go. That should be pusher 2 working, so we should be seeing boxes pushed over here now as well. This one here should get pushed. Alright. So that is that. So that is all of our functioning logic working. We'll come back and comment this a bit later. So our final step here, part data. So what do we want to do for data collection? So we want to track the number of minutes, the number of parts, and the number of parts per hour. So this is just going to be the number of minutes that the conveyor is running, the number of parts we have, and the parts per hour. So if we need to time how long the conveyor is running, for that we're going to need a timer. So let's create a timer. I'm going to call it conveyor run timer. There's a new tag, and we'll turn that on whenever we have what's it called, run conveyor. So whenever we have run conveyor, we'll run this. Now what should our preset be for this? Because we don't want the timer to expire, because then it stops counting. We just want to be able to grab the accumulated value of the timer. So we want a big number in here. So what's the biggest number we can actually put in here? I'm going to try putting in that. If I put it in a huge number, it gives me an error, because I think this says that that number is actually too big. That number is still too big. That is too big. I'm not sure what the biggest number you can put in on a timer is. Okay, it accepted that. So that is 8 nines there. So it accepts that as a value. Okay, so that is a lot of seconds. We will probably not expire that in just a regular timing event. So let's do that. So that's going to be timing how long our conveyor is running for. So if we want to display the number of minutes it's running for, how would we calculate minutes? So we're going to use our favorite math instruction. There's lots of ways you could do this, but I'm going to use the CPT instruction. And again, there's a couple of different ways you could do this. I'll do this the long way. I'll do it the short way first. So this is called minutes display. That's where we're going to put our result. And then how do we get this? So this is going to be conveyor run timer .acc. That's our actual counted value. We need to divide by 1,000 to get seconds, and then take all of that and divide it by 60 to get the number of minutes. So that should give us our number of minutes. And now what you see is basically this counting up. And that is basically how many minutes are going by. And it goes back to 0 when we hit stop. Okay, so that's one way to do it. Another way you could do it, I like to use move instructions. So this is MOV. So what I might do for something like this, I might create a new tag that's just called minutes. And I would make that a real. I like to use a lot of intermediate tags. So I might do this math, put it into a tag called minutes, and then move that tag into the minutes display. Just in case I want to do something else with this tag, I might do it this way. It basically is the exact same thing, it's just one extra step. It's one extra step, but it gives you some freedom to manipulate that intermediate tag down the line if you needed to do that. So this would probably be the way that I would do it, but it is also proper to just go directly to that minutes display in there. Okay, so either way is fine, whatever you like to do. But anyway, that gets our number into the minutes display. Now, the total number of parts. We added this sensor over here, this part count sensor. So if we want to count the number of parts, that is going to be a count up instruction. Let's call that part count. And it's going to be triggered by part count PE. That is our trigger, and let's reset this. If our conveyor is not running, let's do a reset on this. So there we go, we're counting parts. And if we stop, we go back to 0. Okay, so now we have a part count. Let's display that here. So let's do a move of our part count. And remember, this is part count dot ACC, that's the accumulated value of the part counter, over to parts display is the name of the tag for there. So that's now going to show up on there. So there's our count. There's our time. And so now the final piece here, well, how do we get parts per hour? So we're already counting minutes. We're counting the number of parts. Let's count. Let's figure out some math. And we'll just do this one directly there. Parts per hour display. It's going to be our destination. And let's figure out the math for this. So we've got the number of parts divided by the number of minutes, or you could say the number of minutes display, it's the same number, multiplied by 60. So this should be the number of parts per minute. Number of parts per minute times 60 should be the number of parts per hour. Parts is not a tag. There we go, no error. And let's try this. And you'll see this thing calculating away. And as you would expect, the numbers are going to really fluctuate in the beginning. And then the longer this runs, the more it's going to settle onto a fairly steady number. And I think what you're going to find is over time that number is going to settle around 820 or 830 parts per hour that you're going to see. So that it's just continuously being tracked. We got all of our boxes being sorted here. So that is how that works. So this will all need to be commented in order to be complete. But basically what we have is main routine, which consists of 4 JSRs. and then individual logic in each of these. If you wanted to look up where's my logic for pusher 2, it makes it very easy just to say, oh, pusher 2 is in the pusher 2 routine, and there's my logic for it. And none of these are more than 6 lines long altogether, so it makes it pretty easy to find things. This is actually quite a large program now because it's about 20 lines long, but it's organized well. It's in 4 different sections. It's very easy to determine what routine controls what, and if you want to figure out where where the logic is for the conveyor, you just go to the conveyor section. A jam up over there. Why is that not returning? Oh, here's a problem. Notice this. Conveyor 2, that says pusher 1. I did not change that one. That's why that's not working properly. Alright, so that is our conveyor logic. Let's see what our parts per hour is settling on. Looks like it's settling in somewhere in the 840s. 850 parts per hour. Coming up on 4 minutes of runtime altogether. And that is the logic for week number 7. And that shows you how to organize your program using JSR instructions.